I wanted to show now a little bit about how to create a QFace file and what are the capabilities of a QFace file. So for this we will first create an own code QFace files in the QFaces folder. It's just an example folder. So as an example, I choose that we wanted to have a file system access. So we say it should be living in the module file system org example.fs. And it has the ending QFace. So we declare the module org example.fs with the version 1.0, and it has an interface called file system. So far so good. From this we could already start to create source code. Let's try it on the command line and make an output folder, and then I will call the QFace's built-in qtcpp generator. It's on my, I have it already here. It's in my dev folder, QFace downloaded from GitHub, built-in qtcpp. The executable is called qtcpp.python file. It's a Python executable. I just pass in the interface file. In this case, it's org example. QFace. It could also be a list of directories, and then an out folder where it should be executed. So it has already created a lot of files. Let's see how they look like. So it's already org example to generate with a plugin, plugin header, the implementation. Actually, this is an empty implementation, just a stub. This is an abstract file system, and so on. So now the next step would be to modify our QFace file and say get the properties, methods, enumeration structures inside. So our file system should have a current path. So we just say it's string current path, and now it's we have declared a property called of the type string called current path. If you would run the generator again, let's see that two files have been rewritten. If we look at this, this is a QML abstract file. We can see here Q property string current path. So it's already inside. And it has also the implementation. The files are virtual, or the methods are virtual, so we can implement them. And the QML abstract file system is actually, the QML file system is derived from QML abstract file system. And here would be the place where we would override the virtual functions to implement our own functionality. Let's continue on defining the interface we are looking for. So we have string current path. The other thing that we would like to have a model of entries. So these are always the entries of the current path. So if we set the current path to the home folder, then this model should have all the entries of our current home folder. For this we also need to define the entry. The entry in this case is the struct. It maybe has a string called name, which is the file name or the directory name, a string path, so that we can later on identify the entry, and then probably some boolean which says it's is a directory or is a file. This should be enough for the moment. So we save, and if we would now regenerate everything, then it would easily generate the QMS module header file. It will update the abstract file system, but also generate QML entries, our structure as a gadget, and even generate a model for us and a QML variant model. This is just by default, it's always generated. So our code is already much bigger now. So this is the module. The idea of the module is that it's a placeholder for creating our structures, because the structures are gadgets, and gadgets cannot be created from the QML side. So you need to create them from the C++ side and pass them back to the QML side, so that you give a reference from this or a copy, and then you can use it from there and pass it to methods. The other thing, later on he will see that this is also the place, the module is also the place for enumerations where they are listed. This was a design choice. This is our entry now. We have a Q property string name, path is here, is file, and is declared as a meta type QML entry. Our abstract file system has now a new property, the entry model with the entries. This is the read-only model, because models are always read-only. So now we can continue here, and let's say we want to have a bool rename a function, the source to the destination, and maybe a function copy, again source destination, and now we just regenerate. So QML abstract file system was kind of updated. Let's see. So we have a virtual slot, rename, and copy. So these are invocables which we can call from QML later on. Another thing what maybe we want to have, it's an entry. We can add the entry string source, add this, or we can have something where we want to have the standard locations. So we just create an enum called location. We add some members to it. We don't have to give the numbering. Numbering gets out automatically here, but we could add map numbering, documents, and download. Download, whatever. So if we just run the source code generator, you will see that the QML module was updated. So in the module now there's our enum inside. It's already registered as a QEnum. Yeah. Now what we would like to use this somewhere. So we get a string standard location, and we pass in the location with a name location. So we now generate again source code. Now we see we have qstring standard location, and this is like where our enum is located in the QML file system module. So it's the naming convention is we have a prefix called QML. You can change the prefix also. Then it's the last name of your module. The module was org example fs, so file system QML fs module. And the other side is the enumeration location. So this is now our method. And everything is generated. We even have a plugin qface-qtcpp and even a profile, so we can open the profile now in the output folder. So this opens our Qt creator. Yeah, this looks good. So our file system, we can copy everything. So now we could use it already from inside. We need to make install to install it, but then we can use it from QML. And so we currently have no implementation, actually an empty implementation. To provide some implementation, we can just override some of those functions. For example, getting an entry from a source would be possible. Let's do this. So we have a qfile source, actually qfile info probably we will need. And then we need to declare an entry. Oh, it's called QML entry. Entry name equals file. What is it? File name, I guess. Entry path file path entry str entry is file. And we can just return entry. So this would be overwritten, the entry method in our abstract file system. which would mean that the generator is smart enough to detect that we have changed this file and it should not be overwritten. So this is a flag called preserve in the generator. So if you want that this file gets newly generated, you have to delete it, and then it will be automatically the next run be generated. Only files listed in the generated folder will be really always regenerated, so you never should touch them. So this one, never touch them, and so on. That's so far for QFace, for the qtcpp generator. So the qtcpp generator is only one of the built-in generators. You can write your own generator, and this one really creates a QML API based on the QFace interface description. You have, in the interface description, you have modules, interfaces, you can import other modules, you have structures, you have enums, and you have also flags to specialize the enum. Thank you for listening, and goodbye.